Hi, I'm Tom Kite. I'm part of the engineering team here at Audio Precision that put together the 555 hardware and the software that goes with it. And one of the things we've done in the software is we've added a completely new mode to it to interact with the instrument, and we call it bench mode. And up until now, the APx software has been based around a sequencer. The idea being that you added measurements to a sequence that you were interested in, and then when you wanted to, you could just run the sequence and it would run the measurements one after the other. Well, we know that some people like to have a more hands-on approach with their testing, and that they just want to, as it were, play around and see what happens. And that's what bench mode is all about. So here on the screen I'm showing bench mode, and you can see it looks very different from the sequencer if you're used to that. So what we've got is essentially three main areas of the display here. We've got settings, so input and output, things like that. We've got the generator and the analyzer, so what signal are you generating and how are you doing the analysis. And then we've got, well, the results over here. And what we have now is a live view where you're looking at the input signal from the device under test, so in the time domain and the frequency domain. And then we've got a few meters up here as well. We've got level and THD and a couple of other things, and we'll look at that in a little bit. So all of these are live, they're all updating in real time, as you can see. So I have as my device under test just a little mixer here, just for something interesting to look at. So why don't we turn on the generator? And you can see now we're generating a sine wave. That's what's actually coming out of the mixer. And here is the spectrum of that signal. And you can see there's our fundamental at kilohertz, and there's second, third, and higher order harmonic distortion, and plus a noise floor. Pretty much what you would expect, right? And so what I'm going to do right now is just put this panel away, and that gives me some more room to see what's going on here. And so you'll see we've got the RMS level out of the device, about 5 volts or so, and THD, you can see it's about 0.01% distortion, something like that. We've got the phase, and this is the phase between the two channels. So one of the channels is not showing anything, and the other is the phase relative to the first channel. And then we've got gain here. So you can see we've got about 8 dB of gain the way things are set up right now. So I can, if I just play with the mixer here, let's say I reduce the level on channel 1. You can see the level going down in the time domain. A little bit harder to see in the frequency domain, but it's right behind that big spike there. And you can see here now the level has gone down to about 2.5 volts on channel 1. Distortion hasn't changed much, phase hasn't changed much, as you'd expect, and the gain, of course, has gone down because that's exactly what I was doing. All right, so I can fiddle around with that and so on. I could say, change some of the EQ controls on one of the channels, and that will. You can see that's actually changed the phase substantially. This is an analog EQ, so of course the phase changes as the gain changes. And you can also see I've actually bumped up the gain so much. By doing that, I'm actually clipping channel 2 there, and you can easily see the clipping in the time domain and the resulting distortion in the frequency domain. And of course the THD plus N has pretty much gone through the roof as well. So why don't I jack that back down again, back to something reasonable. So there we go. And you can do things like filter the input signal. So for instance, if you are trying to exclude some tone that's in the spectrum that you're not interested in, or you want to limit the bandwidth to a very precisely known value so that you can measure your noise specification, for instance, you can do that. So over here we have a low pass control, and there's some choices, including custom choices, where you say, well, I would like a Butterworth filter and I want it at 20 kilohertz. So you can just type in that corner frequency, and now the system has been set up with a Butterworth. And let me show you that in the frequency domain. I can show you that by making this thing a bit bigger here, and you can see, oh look, there's a corner. You can see the signal rolling off there at 20 kilohertz. Okay, so you can also set up custom high-pass filters if you want. Maybe you've got some hum in your system that you don't want to measure. So, well, why not put a 400 hertz high-pass in there, get rid of all that hum, things like that. And when you do that, it affects the signal in every one of these meters. So it affects the time domain, the frequency domain, and the meters as well. So everything goes through the filters. All right, so let's go back to good old AC coupling. There we go, and let's pop this away again. Now, so of course these are live meters. We can also make measurements as well. So for instance, we can measure the frequency response of the system using continuous sweep. This uses a continuous sine wave sweep to measure frequency response. And there it is. Now you'll see there's actually, it's dominated by the roll off of the filter here. So why don't I turn that filter off? We'll just go back to looking at it over the whole passband of the analog to digital converter, and let's measure that again. And there we go. Now we can get a closer view of what's going on with the frequency response, and you can see you know, it's pretty flat. I mean, it looks like it's not, but remember the graph range here is quite small. It's only about a dB, minus a dB to plus a little bit. So we're looking over a pretty narrow range, and you can see there's some non-flatness there, and that's because, you know, this device has these kind of continuously adjustable EQs, and I'm guessing that they're not perfectly flat even when the controls are right in the middle. That's pretty normal stuff there. There we go. So, but they're you know, it's pretty flat. And at the same time, I've measured phase. Now this is the phase between the two channels, and again you can see it's pretty flat. It's only plus or minus a degree or so. And again, I'm sure that's just because of the, you know, settings of those EQs and so on. But if I radically change the EQ, let me move one of these around a little bit, and let me do an append and do that again, and you can see, well, now the phase difference between the channels looks completely different, and that's because I've, you know, skewed the EQ on one of the channels relative to the other. Another thing we can look at is group delay. Here's group delay versus frequency. You can see it's actually dominated by what's going on at low frequency, and that's probably because of AC coupling. You know, typically there's a resistor capacitor combination which is going to cause a pretty big change in group delay at low frequencies. Otherwise, it's pretty benign. But again, if I change the EQ a little bit, let me just do something like that. Change that on the right hand channel and do that again, then I've got a different response on the right hand channel. So group delay changes a little bit with frequency. Now, one of the features we've added for bench mode is a thing called recorder, and I'm going to show you that here. Let me flip over to the recorder tool, and what this allows you to do is just record parameters of your device over time. So any particular parameter that you're interested in, RMS level, gain, THD, things like that, you can record them as they vary over time. And the way I've set this up, I'm going to record for 10 seconds, but that can be as long as you like. And I'm recording at a reading rate of 32 readings per second. Now you can take that all the way up to 250 readings per second, and you might want to do that if you have a device whose characteristics change very quickly, maybe the attack of a compressor, something like that. But we haven't got such a device here, so 32 readings per second will be fine. And over here you see I've chosen, well, which things am I going to actually record. So in my case, I'm going to do RMS level, phase, and THD plus N ratio. But as I said, that list can be any of the meters in the system. So I just say go, and off we go. And so we are measuring the RMS level at the output of the mixer. And if I change the gains in the mixer left and right, you can see how the RMS level will change over time, as you would expect. So there's a 10-second recording where I was just varying the levels. Now we can have a look at, well, how did the phase change? Well, the phase changed a little bit like that, and here's how the THD change, kind of went all over the place. That's to be expected. If you're making big variations in level, a THD is naturally going to do that. But so we can see how things vary over time. Now, as I said, you can record for really as long as you like, but maybe sometimes you don't know how long you want to record for. Maybe you just want to record until you see something interesting. So we have a mode for that called run until stop. So let me start that. So we're measuring the same things as we were before, but now we're in run until stop mode. So if I vary things, again, you can see how things vary over time. And when we reach the right-hand edge of the screen, then everything starts scrolling. So you can keep measuring, and it'll just keep recording everything, but just showing you this window on the data. And I can flip to another measurement, and I can say vary the EQ here, so which is going to change the phase difference between the two channels. So as I vary the EQ, you can see how the phase changes over time. So maybe I've had enough, I can just stop it, and now I can see that all of that data, it has been recorded and is still in the system. So I can just move around and zoom in, have a look at whatever interests me. You know, maybe something interesting happened at one point where there was a glitch in the system, and you see a little spike in the RMS level or in the THD or something. So you can move around until you see what you want, and then zoom in and examine it. All right, so that's one of the new features in bench mode. I could show you all sorts of other features that we have, but we only have so much time, so we'll have to save that for another video.
Find out more at Vicom's website.